Hi, this is Sammy. Just continuation to my last lesson about quadratic. So last lesson we did change quadratic equations from standard form to vertex form. And I showed you two methods. And I said one of them is easy. It just requires memorizing two formulas, but students find it a lot easier than completing the square. Now we're going to continue into graphing from vertex form. And I'm going to show you three methods. The last method that I'm going to show you is what the students or most students like using because it's just memory work. But I'm going to still show you the three ways. I like the first way myself, but you'll see three ways here, and it's your choice to follow the one that you feel easier for you, and you could apply it, and you're sure not to make mistakes with it. At the end of this video, you'll see the link to the video that I made changing from standard form to vertex form. So watch that, so it gives you an idea how to go from standard form to vertex form before you learn how to graph. Okay. So again, what's happening here, this is the equation in vertex form, and that's what we changed standard form last time into vertex form. And so when you change it to vertex form, then you know your vertex is always P and Q, which is this value and this value. And then the axis of symmetry, which is very important when you're graphing parabolas, which x equals P, so it equals that value that's in the formula right here. So here, we're going to start with graphing this, and to graph this, the first thing we need to do is find the vertex. And the vertex here, always, when you looking at this number, you change the sign of this number, so it's going to be -3, but you don't change this, so that's just +4. And the axis of symmetry is always x equals P, which is x equals -3. We really need the axis of symmetry because once we plot points, we reflect them into the axis of symmetry to get the other points, so we reduce the amount of work we have to do by half. So let's go about this one. First thing, we plot our vertex, so it's at -3 and 4, which is right here. Now, as I said, this method using a table of values. So what I'm going to do, and pay attention to this when you're doing table of values. Sorry, it's my boy kicking the soccer ball here, my 4-year-old. So I'm babysitting him today. So when you're doing table of values, the first thing you need to do, and pay attention to this, is to plot to put this point, which is the vertex, right here. So x and y, and you put and -3 and 4 for your table of values. Okay. After that, you see how this x value is -3. Then take two numbers next to -3. So in sequence, it will be -2 and -1. What you do, you take in the -2 first, you plug it into this equation right here. So if you sub in -2 right here, and you have to do order of operations, so that's -2 plus 3 is 1. 1 squared is 1. And then you multiply it by -2, you get -2. And then you plus the 4, you get +2. So that's 1 point there. And then you try the -1 as well. So -1, you put it in here. -1 plus 2 is, sorry, -1 plus 3 is 2. 2 squared is 4. 4 times -2 is -8. -8 plus 4 is -4. Okay. Now you go and plot this point. So -2 from here, you count from the origin. So -2 for the x and 2 for the y. So it's right here. And then it's -1 and -4. So -1 and -4 is right here. Okay. Now, as I mentioned, the axis of symmetry is very important. So if we just plot our axis of symmetry, after you do that, all you need to do, these 2 points that you plotted already, you reflect them into the axis of symmetry. So this is 1 away from the axis of symmetry. So you go 1 away and you put your other point right here. This point is 2 away from the axis of symmetry. So you go 2 away and you put your point right there. And after that, you have 4 points and the vertex to be able to plot this. And most teachers, they'll ask you to show them 4 points on the graph. So that's what you do. And I'm just going to plot my parabola right here. And that's how my parabola looks like. Okay, so that's the first method. Now we're going to go and explore the second method. So the second method is transformations. So in transformations, we're still going to just find the vertex since we learned how to find the vertex. So the vertex for this graph here is -2 and -1. So let's go and plot it. So -2 and -1 is right here. Okay. Now, what we have here, if we look at this graph and you want to use transformation, this 3 here, it means a vertical stretch, vertical stretch or expansion. By a factor of 3. So basically multiplying all the y coordinates on every point by 3. And then the graph, if you look at this, x plus 2 means the graph moves 2 to the left, plus 2 here inside the brackets means 2 to the left, and -1 outside of the brackets means the graph moves 1 down. So what we do, even I'm going to show you even the this point right here, the vertex. So if you're going to do vertical expansion by a factor of 3, you multiply the y value of this point by 3. The y value here is 0. So if you multiply it by 3, it stays 0. So there's no vertical expansion for any point on the origin there. But then the graph moves 2 to the left and 1 down. And that's how we got our point right here, the vertex. Okay. Now let me map them out. So the other points that I have, and this is, by the way, this is we're going back to y, because this is the y equals x squared. That's your parent graph, you know, when x is 0, y is 0, when x is 1, y is 1, when x is 2, 2 squared is 4, y is 4. So that's what we're using as a reference, the parent graph, to use transformations to graph what we have here. So let's take the point 1 and 1, and the 2 and 4. And if you wish, we could do all of them. So the -2 and 4, and the -1 and 1. Okay. So let's take this point, vertical expansion, a factor of 3. Good afternoon. Yes, I have a question that I need to ask. So vertical expansion, and then 2 units to the left, 1 down. So let's go to this point. If you do vertical expansion, you multiply just the y value by the 3. So that becomes 1 and 3. And then, you know, if you're moving left 2, that means you -1 from the 1, that becomes -1. And if you're moving 1 down, you -1 from the 3, and that becomes 2. So that is another point there. So it's going to be -1 and 2, which is right here. Now let's go to this point right here. Now, when you multiply, as we said, you multiply the y value by the factor of 3. So that gives you 2 and 12. And then if you move left 1, you take away 1 from the 2. So that's 1. And if you move in 2 to the left, you take away 2 from the x value, so that becomes 0. And if you're moving down 1, that becomes 12 minus 1, which is 11. And you know what? Since this is my vertex, you don't even need to do these two here, because let's just plot that 0 and 11. So 0 and 11 right here. And then, you know, this is your axis of symmetry right there. So this is my vertex right here, and I got these 2 points. The other points will be just a reflection, like these 2 points here. When you do the transformation, will be just reflection of these 2 points right here. So if you reflect this one away from the axis symmetry, so you go 1 away and put your other point, and this is 2 away from the axis symmetry, so you go 2 away and you put your other point. That's basically how your graph is going to be right here. So, and then that's how your graph looks like using transformations. I know, like from experience, I know a lot of students don't prefer this method. Now let's go to the method that lots of students like to use. So here with the last method, the first thing you should know is that this parent graph right here from the vertex, so from the vertex, if you notice, you're going out 1, up 1. So you go out 1 and up 1, and then you go out 1 again and up 3. And we'll just keep it right there. I don't want to do the next point. So basically you're going out 1, up 1, and then out 1, up 3. So that's what you have to remember. And you do that from the vertex. Now let's come to this graph right here. This graph is y equals to x squared minus 5. So the vertex here is 0 and negative 5. Okay. Lots of students, they say this doesn't look like this. How did you get 0 and negative 5? I say you could write this as y equals 2x minus 0 squared minus 5. So that's how x minus 0, just x, and that's how we get x squared. So it's 0 and minus 5 is your vertex. Now, you have a vertical expansion by 2. So you have a vertical expansion by 2. So now you see this here out 1, up 1. The out 1 stays the same, but now the up 1, you have to multiply that by 2. So it becomes up 2. So it becomes up 2 instead of up 1. And then out 1, you know how here is up 3. Now you multiply that by the 2 right here and it becomes up 6. So let's go and plot my vertex first. So 0 and negative 5, which is right here. Yeah, so that's a negative 5 right there. So that's my vertex right here. Now what do you want to do? Follow this. Out 1, up 2, so right there. And then from here, out 1, up 6. 1, 2, 3, 4, 5, 6. So my point is right here. Now you know the axis of symmetry after the vertex here. The axis of symmetry. I'm just gonna stick it right here so you know. Is x equals 0. So basically your axis of symmetry is the y is the y axis. So if you want me to plot that like just a dotted line on top of that, that's your axis of symmetry. So now you take this point right here, it's 1 away from the axis of symmetry, and you plot it right there. And this point also is 1 away, 2 away from the axis of symmetry. So you go 2 away on the other side and you plot it right there. And that's basically how you graph your graph. Yeah, so that is how this parabola here looks like. So, and that is the method that a lot of students like because it's basically just remembering this out 1, up 1, and out 1, up 3. And then you look at the factor in here, and that's what you need to multiply this part with when you're doing this. And also just know you're always doing that from the vertex. Once you get the vertex, it'll be out 1, up 2, and then from here out 1, up 6, and so on. Let's say if you say maybe Sammy is not telling us the right thing, You remember I said table of values, and that's the method I prefer, as a matter of fact. So a table of values, you put your vertex first, 0 and -5. And then what you choose the two numbers next to 0. The consecutive numbers would be 1 and 2 after 0. So sub in the 1 here, 1 squared is 1 times 2 is 2. 2 minus 5 is -3. So you have this point right here, and then put in the 2. 2 squared is 4. 4 times 2 is 8. Minus 5 is 3. As you know, this 1 and -3 is right here. 1 and -3, and then 2 and 3. That's 1, 2, and 3. So that's to confirm that what I've done is correct. And this is it. This is the 3 methods to graph parabolas. As I said, a lot of students like this method. Personally, I like the first method because why I like the first method? Because you use that all the time, not only with parabolas, with every graph. And it doesn't matter how hard the graphs get, you could always do a table of values to know and to assure yourself of what you're doing is right or wrong. The only thing with table of values is make sure when you do it, your order of operations is correct, you know, and also if you're squaring a negative number, it becomes positive and all of that. These are the kind of mistakes that students make. And that's it for today. As always, thank you for watching. Don't forget to hit the like button, share with family and friends, and subscribe to my channel. Thank you for your support. Till next time, bye-bye.